Even or odd signal. Even signal is said to be even if inversion of time axis does not change the amplitude. The another name for even signal is symmetric signal. Even signals are also called as symmetric signals, and they are represented as x e of t. Whereas the odd signal is said to be an odd if inversion of time axis also inverts amplitude of the signal. It's also called as asymmetric signal. Asymmetric signal. And the representation is x naught of t. So these two are the conditions of even signal, and these two are the conditions of odd signal. Now when original x of t is equal to time reversal signal, it is said to be an even signal. So this is a condition for continuous time signal, and the second one is the condition for discrete time signal. Whereas when x of t is equal to inverse of amplitude as well as inverse of time, it is said to be odd signal of continuous time, odd signal of discrete time. So these are the four conditions for even signal, odd signal at continuous time and discrete time. And these are the four graphs underneath. The first two is for the even signal, the third and the fourth is for the odd signal. So now this is for continuous time, this is for discrete. This is for continuous, this is for discrete. Now let's write the equation for even signal and odd signal. The condition for even signal, the equation for even signal is x e of t is equal to half of the original signal x of t plus the time inversed signal. So this is the condition for even signal. For odd signal, it is x naught of t is equal to half of x of t minus x of minus t. Okay, and the next is x of e for discrete time. Even signal for discrete, it is half of original signal plus the time reversal signal. Whereas for odd signal, it is half of x of n minus x of minus n. So these are the four equations which will help you to find whether this given signal is even signal or odd signal. The sum of the two, the sum of both even signal and odd signal is called as the original signal. That is x of t is equal to x of e into t plus x naught of t. Determine and sketch even and odd part of signal x of t. So here is a continuous signal x of t is given. You are asked to sketch even and odd part. When x of t is given, you have to draw for x of minus t, because to find even and odd, we need x of t and we need x of minus t. So minus t is nothing but time reversal. So for this, the time reversal signal will be 0, 1, 2, minus 1, minus 2. Whatever is here, it will go here, and whatever is here, it will come here. So it will be 1, 2, 3. That is the amplitude. So this is your time reverse signal. So we have found out x of t, x of minus t. And then we have to, please write the equation. X of t is equal to sum of even signal and odd signal. Here even signal is written as 1 by half of x of t plus x of minus t. Whereas odd signal is written as half of x of t minus x of minus t. So half of adding these two will give you even signal. Half of subtracting these two will give you odd signal. Let's start with the even part. For even part, consider equation 1. Okay, this equation is considered. Write all the instances. So when t is equal to minus 2, t is equal to minus 1, t is equal to 0, t is equal to 1 and t is equal to 2. There are 5 instances that has been considered. So at t is equal to minus 2, substitute in the equation 1. So your x of e power minus 2 will be half of x of minus 2 plus x of minus 2. Next, x of e power minus 1 will be half of x of minus 1 plus x of minus 1. Now, this represents the amplitude of x of t. And this side, your right hand side represents the amplitude of x of minus t. Okay, so next x e power 0 will be half of x of 0 plus x of 0 again. 1 will be half of x of 1 plus x of 1. Then it is 2 is equal to half of x of 2 plus x of 2. Yes. Now, let's solve it. It is half of, what is x of minus 2 of x of t? It is 0. Okay. And x of minus 2 for x of minus t, it is again 0. So, 0 plus 0. That is nothing but 0. Next is half of, what is the amplitude at x is equal to minus 1? It is 1. What is the amplitude at x is equal to minus 1 of x of minus t? It is again 1. So 1 plus 1. This becomes 2 by 2, nothing but 1. And then find out the next amplitude at t is equal to 0 and t is equal to 0. Here it is 2 and here it is 3. So half of 2 plus 3. That is 5 by 2. 2.5. Next, at the instant 1 and 1 of x of t, x minus t. So here it is 1, here again it is 1. So half of 1 plus 1. 2 by 2, 1. And the last, at 2 it's 0, at 2 again it is 0. So half of 0 plus 0. That is 0. So these are the new amplitude value for the corresponding time. Okay, so this is the amplitude for the even part. Now let's draw the graph for the even signal. Having the time instance and the corresponding amplitude, let's draw the graph. Okay, t, x of e of t, even part. Okay, we have only solved for even part. 0, 1, 2, 3, minus 1, minus 2, minus 3, 1, 2 and 3. Please draw. At t is equal to minus 2, it is 0. At t is equal to minus, it is 1. At t is equal to 0, it is 2.5. So this 2.5 lies somewhere between 2 and 3. Next, at t is equal to 1, it is 1. At t is equal to 2, it is 0. Okay, so the graph will be, this is the new graph for even signal. Next, let us solve for the odd part of the signal x of t. So again, x of t is taken, x of minus t is taken, and the 3 basic equations are written. Okay, to find the odd part, consider the second equation, x0 of t is equal to half of x of t minus x of minus t. So take down the instant. It is very same as your even part. Okay, so it's same thing. X t is equal to minus 2, t is equal to minus 1, 0, 1 and 2. The 5 instances are taken. And now write for x o of t, it's minus 2. It is half of x of t. So x of minus 2 minus x of minus 2. You have to subtract the 2 signal. X of minus 1 minus x of minus 1. Then it is odd part of 0. Half of x of minus, no, x of 0 minus x of 0. Then it is for 1. Half of x of 1 minus x of 1. And then comes your 2. Half of x of 2 minus x of 2. Now let me repeat. This side represents the amplitude of x of t. Okay. Whereas the other side represents the amplitude of x of minus t. Okay. Now then we'll solve. It is half of x at minus 2. It is 0. Again it is 0. So 0 minus 0. It will be 0 minus 0. That is nothing but 0. And then at t is equal to minus 1. The amplitude at x is equal to minus 1. It is 1. Here again it is 1. So it will be half of 1 minus 1, which is again 0. The third, at t is equal to 0, find the amplitude of x of t, x of minus t. So here it is 2, here it is minus, 3. So 2 minus 3. So it is half of 2 minus 3. That is minus 1 by 2, which is nothing but minus 0.5. The second last, at t is equal to 1. Okay, it is 1 here, the amplitude is 1. So half of 1 minus 1, it is 0. And then again, it is at 2. Okay, 0 minus 0. So half of 0 minus 0. That is nothing but 0. So these are the newly found amplitude for the corresponding time for odd signal. Now let's draw the signal having the amplitude and time instance. So it is 0, 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, minus 1, minus 2. This 0 is a little bigger, we'll draw it small. Okay. So at minus 2 it is 0. At minus 2 amplitude is 0. Minus 1 again 0. Next is t is equal to 0. The amplitude is minus 5. So it comes here. Okay, minus 5. And then at t is equal to 1, the amplitude is again 0. And when t is equal to 2, the amplitude is again 0. So here it is 0, here it is 0. So the signal will be drawn like this. Okay, the signal is supposed to be drawn like this. Now this is your x of odd signal. So earlier we drew the even part and this is the odd part. Together we have sketched both even and odd part of the signal x of t.